In this class, we are going to have a detailed analysis on the set theory. What is a set? A set is a well-defined collection of distinct objects. Example, the collection of all the boys of your class and the set of vowels, etc. It is a very simple definition of the set, but you all must know the two things. What is a well-defined collection and what is the meaning of distinct objects? A well-defined collection means if A is a set and A, E, I, O, U are the members of that particular set. Suppose A is the set of vowels in English alphabet and A, E, I, O, U are the members of A, then about any element or any member of A, we have no doubt that whether they are vowels or not. It is universally accepted as vowels. So, we have no doubt about the A whether it is vowels or not, and same in the case of every element of A, we are sure that they are vowels. This surety is known as well defined. They are recognized as vowels universally. The second one is distinct objects. Distinct objects means every element of the set must be different from each other. It means that no repetition is allowed. For example, A, E, I, O, U are all different elements. If we write A, E, I, O, U, then we can't call it as a set because it doesn't satisfy the second property, that is distinct objects, because A is repeated twice and both A and A are the same. As per our condition, all the elements and all the members of a set must be different from each other. We can't say that the collection of the most talented singers of India and the collections of all the intelligent students in your class are sets. Why is it so? Because there can't be a universally accepted singer which we can say that it is the most talented singer of the world. But everyone have different criteria for determining their favorite singer. So when you ask the individuals about their favorite singer, they may have different opinions. Thus, there is no any well-defined collection for the singers to be the best singers of the world. Same in the case of intelligence. If you ask to the maths teacher who is the intelligent student of your class, then the student who is good in mathematics, he will take his name. Same in the case, if anyone is good in the dance, then as per dance teacher, that person is intelligent. So intelligence may vary from sphere to sphere. So there can't be a well-defined collection of intelligent students in the class, because everyone has the different opinions. Note that the objects that belongs to a particular collection or the set are known as its members or elements. Sets are usually denoted by the capital letters, that is A, B, C, X, Y, etc. There are two different methods for the representation of a set. The first one is roster form or tabular form, and the second one is set builder form. In roster form, all the elements of a set are listed, separated by commas and enclosed with a curly braces. For example, the set of vowels of English alphabet may be described in roster form as V equals to A, E, I, U, O, U, and it is enclosed by the curly braces from both sides. Two things must be noted. In roster form, the set is enclosed by the curly braces and every element of the set is separated by the commas. While writing the set in roster form, the elements should not be repeated. If there is repetition, then it will remain same. For example, there is repetition in L in this word follow. The L is twice and O is also twice, but in the case of representation it as a set, we will consider it only once. Next is set builder form. In this form, a set is described by the characterizing the property of the elements. For example, in the set A, 1, 2, 3, 4, all the elements possess a common property. And what is that? These all are natural numbers below 6. So it can be written as A equals to X such that this column is known as such that X is a natural number and X is less than 6, and is read as the set of all the X such that X is a natural number and X is less than 6. The main thing is that you must know the property of the elements. Then you can write in this form. Rather than representing all the elements 1, 2, 3, 4, 5, you just write that A equals to X, where X is a natural number such that X is a natural number and X is less than 6. You can also use the special symbol, for example, such that X belongs to N, which is N is a natural number. And in mathematics, when there is N, everyone knows that it is representing the natural numbers. You can also represent it in this form. Let A equals to X, where X belongs to N. We all know that N represents the natural numbers and X is less than 6. You all must be familiar with the following notations. The capital N represents to the set of all natural numbers, that is, the number starts from 1 to infinity. Z is the set of all integers. Integers refers to all the positive and negative numbers as well as 0 on the number lines. W is the set of all whole numbers, that is, numbers start from 0 to infinity. Q is the set of all rational numbers. Rational numbers are the numbers in the form of P by Q, where Q is not equals to 0. For example, 3 by 2, 4 by 3, these all are rational numbers. We can also say that 2, 3, 4, etc. are also rational numbers because there is always an imaginary 1 in the denominator. 0 is also a rational number as it is on 1, because if it is 0 by 0, then it will become to infinity. Similarly, we can also say that minus 2 is also a rational number because there is an imaginary 1 in the denominator. If we can say that minus 2 is upon the minus 1, then both negative and negative cancel out. We left with only positive 2. So we say that even minus integers also divided by an imaginary 1. So it remains minus 2 itself. Then what is R? R is the set of all real numbers. Real numbers include the rational as well as irrational numbers. Rational numbers are the numbers on the number line that include fractions, integers, terminating decimals, and repeating decimals. The two important terms here are terminating decimals and the repeating decimals. What are the terminating decimals? Terminating decimals are those decimals which end on a particular point, like 2.52. It does not move on, it ends at a point. And a repeating decimals like 2.515151 continuously repeating, or 2.555. These are known as repeating decimals and these are the rational numbers. All the rational numbers can be marked exactly on the line on a number line and on a well-defined points. The irrational number are on the number lines non-terminating and non-repeating, like 3.141592. It is repeating forever and thus we can say that it's not terminating and it is not repeating. Look here, this is 1415926535. There is no any particular repetition in this sequence. They can't be written as a fraction, but they still exist between the numbers. And which numbers? Between the rational numbers. Rational numbers are represented on a particular points on the number line, and the irrational numbers are in between the rational numbers. You all may be familiar with the concept that a number line is always left with small holes after we plot all the rational numbers, and these holes are filled by irrational numbers. What is subset in maths? Let set A is said to be the subset of set B if all the elements of A are also present in set B. In other words, set A is contained inside set B. For example, if A is equals to xy and B equals to xyz, so you can see that the complete A is the part of B. So we can say that A is the subset of B. In set theory, the subset is denoted by a particular symbol, and it is read as is a subset of. So when you write A, the symbol, and B, we can say that A is the subset of B. A subset can be equal to the set. That is, subset can contain all the elements present in other set. For example, A equals to x, y, z, and B equals to x, y, z. Then also we can say that A is the subset of B. So when A equals to B, at that time also A is the subset of B. What are the types of subsets? Subsets are classified as proper subset and improper subset. The basic difference between these two are, in the case of proper subset, A is not equals to B, but in the case of improper subset, A is equals to B. It is denoted by only subset symbol, but it is denoted by subset as well as equality symbol. So it is improper subset and it is proper subset. When A equals to xy and B equals to xyz, at that time A was not equals to B. So we simply said that A is the subset of B. And which kind of subset it is? It is proper subset. But when A equals to x, y, z, B is also equals to x, y, and z, at that time too A is the subset of B. But what kind of subset? It is improper subset because A equals to B. So we put a symbol of equality under the symbol of subset of. So a proper subset is one that contains a few elements of the original set, whereas an improper subset contains every element of the original set along with the null set. What is a null set? Null set is denoted just simply by phi or by braces. For example, if A equals to set A equals to 2, 4 and 6, then the number of subsets equals to 2, 4, 6, 2, 4, 4, 6, 2, 6, 2, 4, 6, 5, and it can also represented by empty braces. The phi is also represented by the empty braces. These all are the subset of this particular set A. Now, what are the proper sets here? The proper sets here are 5, 2, 4, 6, 2, 4, 4, 6, 2, 6, and the improper subset is 2, 4, 6 because improper set should be equals to the original set because it contains all the elements of the original set. So here set A equals to 2, 4, 6, that is improper set. So we can say that A is the, or we can say that this improper set is the improper subset of set A. There is no particular formula to find the subset. Instead, we have to list them all to differentiate between proper and improper one. means we can't find the number of subset without differentiating between the proper and improper one. Let's calculate how many subsets and proper subsets does a set can have. If a set has n elements, then the number of subset of the given set is 2 power n, and the number of proper subsets of the given subset is given by 2 power n minus 1. The total number of subsets will be 2 power n, where n is the element within the given set, and if we want to find out the proper subsets among those, we have to take 2 power n minus 1, and the remaining will be improper subsets. Consider the following example where a equals to a and b. Then the proper subset of the given subset are: one is empty set, that is phi, a and b. Here the number of elements in the set is 2, because how many elements are there? Only 2. We know that the formula to calculate the number of proper subset is 2 power n minus 1. So here 2 power n equals to number of elements or number of members, that is 2. 2 power 2 minus 1, that is 4 minus 1, which is equals to 3. Thus the number of proper subset for the given set is 3, that is phi, a and b. What about the total number of subset? That is equals to 2 power n, and in this case n equals to 2, then 2 power 2 equals to 4. The total number of possible subsets are 4 by including proper as well as improper subsets. Among them, the proper subsets are 2 power n minus 1, which is equals to 2 power 2 minus 1, which is 4 minus 1, that is equals to 3. Then how many improper subsets will be there? 4 minus 3 equals to 1. Only one improper subset, that is equals to a comma b, because the improper set is equals to the original set. The subset which contain all the elements of the original set is called an improper subset, and it is denoted by the symbol of subset as well as equality. So we can say that it is the symbol of improper subset, and for the proper subset we use only this one. For example, set P equals to 2, 4 and 6. Then the subsets of P are: how many elements are there? N equals to 3. Then 2 power 3 equals to 8. 8 possible subsets are there. Among them, how much would be proper sets? That is 2 power 3 minus 1, which is equals to 8 minus 1 equals to 7. It means that 7 proper sets are possible and 1 will be improper subset. That are 5, 2, 4, 6, 2, 4, 4, 6, 2, 6, and the last one is the complete set, that is improper subset 2, 4, 6, where 5, 2, 4, 6, 2, 4, 4, 6, 2, 6 are the subsets. Which kind of subsets? Proper subsets, and 2, 4, 6 is the improper subset. Therefore, we can write that 2, 4, 6 is the improper subset of P. Note that the empty set, which is denoted by the empty braces or phi, is an improper subset of itself. Phi is the improper subset of itself, but it is a proper subset of any other set. It is the improper subset of itself because it is equals to itself, but it is a proper subset of any other set. So if there is 2, 4 is a set, then we can say that phi is also a proper set of this set A. So in the case of proper subset, which is denoted by this symbol, where A is not equals to B. Whereas in the case of improper subset, A is equals to B. Power set is said to be the collection of all the subsets. It is represented by PA, and if the set A and B is given, then the power set will be phi A, B and AB, where these three are the proper subset, where A, B is the improper subset, which includes all the elements of the given set. Properties of subsets. Some of the important properties of subsets are: every set is considered as a subset of the given set itself. It means that if X is given a set, then X is said to be the subset of itself. Every set is the subset of itself. In the same way, Y is the subset of Y. We can say an empty set is considered as the subset of every set. Empty set means phi is the subset of every set. If X is a subset of Y, it means that X is contained in Y. Complete X is present in set Y. If set X is a subset of set Y, then we can say that Y is the superset of X. So, how can we represent? Y is the superset of X. If all the elements of X or elements of Y, it means that Y is equals to X. That in that case, it is the improper superset. But if Y is not equals to X, at that time we can say that Y is simply the superset of X, just the reciprocal of the subset. Real life examples on subsets. If we consider all the books in a library as one set, then the books of mathematics will be the subset. If all the items in a grocery shop form a set, then the cereals form a subset. Note down this example and try for yourself, and you can answer it in comment sections. Types of sets. Singleton set. A set consisting of a single element is called the singleton set. For example, let x equals to x such that 1 less than x less than 3 and x is a natural number. So, we know that it can be only 2 because the 2 is only the natural number that lies between 1 and the 3. This is a singleton set as only element of the set B is 2. Empty set. A set which does not contain any element is called the empty set or null set or the void set. It is denoted by the symbol phi or empty braces. For example, let x such that x is a month of the year starting with alphabet B. So, none of the months starts with B. It can say that it is a void set. Finite set. A set which is either null set or whose elements can be numbered from 1 to n. For some positive integer n is called a finite set. In other words, a finite set is either an empty set or has a definite number of elements. For example, we can say that the natural number from 1 to 7 is a finite set. It has both the n points. And a null set is also a finite set. Infinite set. The number of the elements in this set is infinite, and moreover the elements of this set cannot be listed by positive integers, such as set is called an infinite set. Examples: the set of natural numbers 1, 2, 3, 4 means the set of complete natural numbers which starts to 1 and move up to infinity. It is infinite set. At the ending point is not definite. The set of even natural numbers. It is also infinite because it is moving on up to infinity. All the infinite set cannot be described in roster form. So we can represent them in set builder form, such as A equals to x such that x belongs to the natural numbers. The power set. As we already discussed that power set contains all the subset present in a particular set. In this case, our power set will be 2 power 3 because number of elements are 3, which is equals to 8, and this one contain all the improper as well as proper subset. Let A be the set with 1, 2 and 3. Then the set of all the subsets of A is called the power of set of A. It is denoted by PA. Thus, in the above example, if A equals to 1, 2, 3, then PA, that is power of A, equals to 1, 2, 3. This is infinity, that is 5 or null set. It is 1, 2, 3, 1, 2, 2, 3, 1, 3 and 1, 2, 3. Among these, this one is improper subset while all others are the proper subsets. Therefore, PA equals to 2 power n, where n is the number of elements in the A. The number of proper subsets of A having n elements is given by 2 power n minus 1. That we already discussed that if we have to calculate the proper subsets, it will be 2 power n minus 1, and the remaining will be the improper subsets, and total subsets formula is 2 power n. Universal set. A set that contains all the objects or elements in a given context is called the universal set, and it is denoted by the U. For example, let A equals to the set of all even natural numbers and B equals to the set of odd natural numbers. Note that natural numbers are the subset of integers and integers are the subset of rational numbers, and rational number is the subset of the real numbers, which includes rational as well as irrational numbers, and all these sets are the subset of the universal set. It means that universal set is the superset of all these. Here, universal set is the superset of rational numbers. Rational numbers are the superset of real numbers are the superset of rational numbers, and the rational numbers are the supersets of the integers, and integers are the superset of natural numbers. Hence, universal set is the superset of all the sets under consideration. Cardinality of the set. The cardinality of a set means the number of distinct elements in the set. It is denoted by modulus A or NA. N means number of elements in the A. If A equals to 1, 2, 3, 4, then the cardinality of A will be equals to 4 because there are 4 elements present. Cardinality equals to the size of the set. The cardinality of infinite set is infinity. Next, what is an interval? An interval is a set of all the real numbers between a given pair of real numbers, excluding or including one or both of these real numbers. Let's suppose here we have a set of natural numbers from 1 to 6. If we say that take all the natural numbers between 1 and 6 by excluding 1 and 6. So, we will not consider 1 and 6. It will be open interval. And if we include both 1 and 6, it will be closed interval. And if we consider only 1 but not 6, then it is semi-open or semi-closed. In the same case, if we consider 6 but not 1, then also it is semi-closed. We have to use the following brackets to determine this. If both side is closed, it is completely closed, then we will represent by this bracket. And if it is from both side open, we will use the following braces. And if it is semi-open, on the side it is closed, we will use the closed one, and on the side which is open, we will use this braces. If it is open from this side, we will use this, and if it is closed, then we will use the following brackets. Now wherever you see this kind of brackets, you will understand that it is closed from both sides. If it is like this and it is open from both sides, if it is given like this, it is closed from this side but open from the end, and this one is open from the starting and closed at the end. Next is very important concept and very easiest concept, that is Venn diagram. What is a Venn diagram? A Venn diagram is a picture that shows the relationship between the different sets using circles. Each circle equals to a set. The overlap is the common element. For example, we have two sets A and B. If these sets have no common element, then they will never overlap, but if they have one or two elements in common, they will overlap. It will show that this portion will show that intersection. So the overlap, if they overlap on each other, it shows the intersection. And common elements, if they are non-overlapping, means separate, so it shows that both sets are different from each other. Example, people who like tea in the set A and set B contain people who like coffee. Then the overlap is A intersection B. It means that people who like both tea and coffee. It is named after an English logician, John Van. In Venn diagram, we represent a rectangle which is our universal set. And we know that all the sets are the subsets of the universal set. So here will be A and here will be B, and remaining portion will be the other sets other than A and B. Suppose A equals to 2 or 4. Our universal set equals to 1, 2, 3, 4, 5. A equals to 2 and 4. Represent the relationship between U and A using Venn diagram. How we will represent? This is a complete set which is U. Here is 1, 2, 3, 4, 5, and this particular portion is the set A, while other remaining portion is other than A. So it is complete union of the multiple set, or we can say that it is the universal set. A is only just a part of this universal set. Now the real life examples by using Venn diagram. If set A is the people who use the Instagram and set B are the people who use YouTube, then it is the Venn diagram where this set shows the Instagram users while this set shows the YouTube users, and the complete rectangle represent to the universal set. Now this circle shows the Instagram users only, and this circle shows the YouTube users only, but their intersection point or overlapping point shows Instagram intersection YouTube, means the people who are using both Instagram as well as YouTube. And the remaining portion shows that people who are not using Instagram as well as who are not using YouTube. Next is the example of bank account. Let set A be the people with the saving account and set B with the people with current account. If we want to calculate A minus B, that means the people only with the saving accounts, then we will subtract the current part from saving accounts. And if we only want to know the current accounts, then we will subtract this saving portion from current account. And if we want to know both A intersection B means that peoples with the both accounts, then it is this intersection part. We will know that where the A is intersecting B, or the saving account user intersecting current accounts users. Let me explain with the help of an example. If A is 1, 2, 3, 4, 5 and B is 3, 4, 9, 11, then if we subtract B from A, what will be the answer? A minus B. Then here the common element is only 3 and 4. We will subtract these elements from set A. What will be left? 1, 2 and 5. So this will be the answer for A minus B. In the case of B minus A, we will subtract the A elements from B. What are the common elements? 3, 4. 3, 4 are only the elements of set A in the B. So we will subtract these 3, 4. What will be left with? 9 and 11. The same logic is using in this case. And if we want to know A intersection B, then we have to find out the common elements between the both, that is 3 and 4. So A intersection B equals to 3 and 4. Next is operations on the set. First one is union, which is denoted by U. Union of two sets A and B is the set of all those elements which are either A or either B. For example, if A equals to 1, 2, B equals to 3, 4, then A union B will be equals to 1, 2, 3, 4. All the elements of A as well as B. But if anything is repeating, we will consider it only one time. For example, if 3 is here also and 3 is here also, we will take 3 as a common element, because we already studied that within a set there is no repetition. So we understood that all the elements, we will unite all the elements of A and B. It is known as union. Next is intersection. Intersection of two sets A and B is the set of all the elements which are common to the both A and B. It means that that element is common in both A and B. Then we will get intersection. A intersection B equals to which element present in both? That is 4. Only 4. A overlap B, or A intersection B equals to 4. What is difference? If A equals to 1, 2, 3, B equals to 2, 3, 4, then understand what we have to do. If we minus A minus B, then we will take all the elements from A which belongs to B. So here if we take A minus B, then here A equals to 1, 2, 3. From this we have to subtract the B's element. B's elements are 2 and 3. So we left with 1 only, because 2 and 3 are the elements of B. We will subtract the elements of B from A. In the same way, if we minus A from B, then we will subtract the elements of A from B. So in this case, the elements of A are 2 and 3, and we will subtract these two elements from B. We will left with B minus A equals to 4. Complements. Complement of a set A, which is a set of union. The universal set is the set of all the elements of U which are not the elements of A. For example, this is the complete union set and this is A. So the rest of remaining part will be considered as A complement, which not belongs to A. A complement means not belongs to A. For example, union set is 1, 2, 3 and A is equals to 1 only. Then what will be the A complement? Other than A. All the elements other than A will be known as A complement, and that are 2 and 3. So A complement equals to 2 and 3. Next is De Morgan's law. De Morgan's law equals to, for any two sets A and B, that is A union B complement equals to A intersection A complement intersection B complement. Firstly, understand what is A union B, then we will discuss that what is A union B complement. A union B, in this case, the A circle which represent the A portion, area of A, and B circles which is the portion of B. So A union B means both the area of A circles as well as the area of B circles. And if we talk about A union B whole complement means the area of A union the area of B, the complement of both A and B. Understood? So this part represent A and this part represent B. Other than this, every portion is A complement intersection B complement. Why intersection? Because A complement, this is A and this complete is A complement. Understood? And if here is B, the whole portion is B complement. So we can say that this portion is A complement as well as this portion is B complement. So it is A complement intersection, means overlapping. A complement is overlapping the B complement. And if we talk about A intersection B whole complement, then first understand that what is A intersection B. If this portion is A and this portion is B, then the intersecting or overlapping portion is A intersection B. Intersection means overlapping. Here A and B both are overlapping. And as per De Morgan's law, A intersection B whole complement means the complement of this portion will be A complement union B complement. So what is A complement? We already know that this entire part is A complement. And what is B complement? If this is B, then this entire portion within the universal set is B complement. That will be equals to A complement union B complement, means the portion which come under the A complement, this one, this complete is A complement, it will unite with B complement. And what happens when we take union? We remove the repeating objects. For example, if A is 1, 2 and 3, B equals to 2 and 3, and universal set is 1, 2, 3, 4, 5. So what is A intersection B complement? Here A intersection B will be 2 and 3. 2 and 3 will be A intersection B because the common element of A and B. So A intersection B whole complement, we have to take the complement of these two. What will remain as per the universal set apart from 2 and 3, that is 1, 4 and 5. That De Morgan's want to tell us by using this Venn diagram. If A intersection B is 5, means that there is no intersection. A and B are two separate sets, means no intersection. Then A union B will be equals to NA plus NB, means A equals to 1 and 2 and B equals to 3 and 4, means no common element, no intersection. Thus, if we unite this, if we take union of this, then NA plus NB, which is equals to 1, 2, 3 and 4. At that time, we have A union B equals to NA plus NB. In the case of intersection is not equals to not equals to 5, at that time we will take NA plus NB minus intersection portion, because when we will take A, this portion is calculated, and when we will take B, this portion is also calculated. So in order to avoid this calculation twice, we will subtract it one times. So NA plus NB minus N into A intersection B. These all for today's class. For the MA Economics course, this much set theory is enough. In the next class, we will solve some questions regarding the set theories. Thank you.